day 640 off the grid and looking at that gap in the sky where that tree used to be. Probably didn't help much today. It looks like it might have been a nice day, but in fact it wasn't really. It was actually quite overcast and raining for most of the day. It's just kind of cleared up in the latter parts. Our neighbours have got their generator running, as you might be able to hear, but we haven't had ours going. Not once since we got back from Castle Point. But I did actually do some work on solar today, so I'm going to show you. In fact, see this space here? This is where all the battery chargers for generator charging had been sitting all winter. I cleaned them out before we went away. Haven't needed to put them back, although I still will need to in the case of needing the generator again, because I haven't come up with a permanent solution for that yet. But one thing that's been really irking me is the balancing of my L12 batteries here, particularly these left hand side ones, which are a couple of hickledy-pickledy older ones. And I did make a very clever whiz-bang battery balancer that I called an analog computer-based battery balancer, because what it in fact did was measure the halfway point of what it should be and then turn on a MOSFET in a linear mode to supply charge to the battery that was lacking, which was always the lower one, and charge them evenly. And while that circuit did work really well, it was a bit of a pain in the ass because it needs an external power input from the solar array separate to the normal charging currents. It also, I felt, took too much power from the main array on overcast days, so I was going to need to come up with a way of mitigating that, which was, more hassle. But I really needed to get on and permitize this because it's been holding up further work in the shed here. It's been holding up tidying up these batteries and everything, really. So I finally got onto it, but I've gone back to a simpler, more typical brute force approach now. This is what I'm trying at the moment. So this afternoon I actually got a chance to do some electronics, some actual electronics, soldering things together, and I've built this little unit up here. It's basically simply a shunt regulator using a MOSFET run in a linear mode, because from my previous circuit I did get to the point where I trusted the idea you could run a MOSFET in a linear fashion. But here we have a simple shunt regulator. It's a common circuit, many people have built it, not necessarily using LEDs, but you've got a Zener diode, a voltage reference, which in this case is the LEDs, and when the voltage starts creeping above that point, well, the voltage of the reference plus the turn on voltage of the transistor, in this case it's a logic level MOSFET, so that's about 2 volts, it will start turning on the transistor and passing current. And the current now is simply being taken from this battery here, from this clip lead over here and this clip lead here. So that will basically turn on and start shunting current around that battery. I have put this bulb here as a resistor in series with it. That may not stay there. It depends on how it performs. The problem with having a resistor there, of course, as soon as current will flow, this will start developing a voltage, which will kind of negate the balancing effect, because it would allow the voltage at this point across here to rise up. So that may not stay there. But in the meantime, it's a good safety measure in case at some point excessive currents get drawn. So really simple in operation. This transistor passes no current till it gets up to about the threshold, which I've set to be around about 7.2 volts. Then it'll start to conduct, and when it does, it'll route current around that battery, and so this lower battery, which is the one that doesn't get charged up as much, will get more of the current. But the disadvantage of this approach, as opposed to my previous circuit, is it will only do it at the top end of the charge. Like this battery has to this battery here has to get up to at least 7.2 volts before anything starts to happen, whereas my previous analog computer circuit was really awesome in the sense that it will attempt to balance the batteries at all stages of charging. Not discharging once there's no feed from the solar power, but it would do it at all stages of charging. So in some ways it was a better solution, but kind of a messy one, you know. I just wanted something that has got two terminals. Two terminal solutions are nice, you know, an input wire and an output wire, positive, negative, whack it across the battery, there you go. So that's what I've done on day 640, but I'm going to have to wait a few days to see if this does the trick. And if this does the trick, then it's the way I'm going to stay, because it automatically doesn't do anything when the weather is bad, because the voltage will never get that high on those kind of days. So it is a simpler way. But is it the best way? We shall find out.